let us talk about the periodic table. We are on page 46 and into page 47 of your textbook. What we need to talk about with regards to the periodic table is how it came about to be, and as such the contributions of two scientists in particular, Mendeleev and Dobereiner, right, which you can read about in the textbook. In looking at the periodic table, if you don't know what it is an important one-page document which summarizes elements, or categorizes elements, I should say, based on their physical and chemical properties, such that those with similar properties would be close by together. So let us look at the contribution of Mendeleev and Dobereiner to the development of the periodic table. So here we're going to say that Dobereiner, what he did was he grouped elements together, and he grouped elements that had increasing relative atomic masses together, where the elements of increasing relative atomic mass had similar physical and chemical properties. Mendeleev later on also arranged these elements in increasing relative atomic mass, so he kept that the same. However, he placed elements with similar chemical and physical properties together. So you're going to take this down as a note. Let us look at page 47. The heading is the modern periodic table, into page 48 of the textbook, which talks about the fact that the periodic table, which consists of elements, means we can divide the modern periodic table into metals and non-metals. So in our periodic table, we're going to find the metals on the left-hand side, and we are going to find our non-metals on the right-hand side. In the periodic table, as you're going to read from the textbook, so here are our metals, here are our non-metals, but there is another category of elements which are called metalloids, and metalloids are said to be intermediate in character between metals and non-metals. Metalloids you would be familiar with from Form 1. The metalloids here sit on what we call a staircase. I need you to know the elements which are metalloids from the first 20 elements. So that would be, you're going to see them here, boron and silicon. And the elements below would be the other metalloids. So for example, that would be germanium, astatine, antimony, tellurium, and polonium. You definitely need to know the two metalloids from the first 20 elements. In our periodic table, as we said, we have metals on the left-hand side, non-metals on the right-hand side, metalloids, and in the center of the periodic table between here to here, you're going to find a group of elements called the transition elements. In looking at our periodic table, we also need to be able to classify or categorize our elements. So let's take a read from the textbook. From page 47, it says, the modern periodic table is arranged in order of increasing atomic number. Elements in the periodic table can be divided into metals and non-metals. So I'm turning to the next page. Some of the elements in between metals and non-metals are called metalloids, and you're given the metalloids from the periodic table. And on the line below the periodic table, it says the periodic table is divided into vertical columns called groups and horizontal rows called periods. So we are going to classify our periodic table in the same manner. So I'm going to pull out a black ink color pen here, and we're going to do that. So in our periodic table, we say that there are groups. The vertical columns are called groups, and the horizontal rows are called periods. The vertical columns, which are the groups, are numbered from here. So this is group 1, group 2, and we go straight across here to group 3, group 4, group 5, group 6, group 7, and this last group here is known as either group 8 or group 0. Right? So these are all given Roman numeral numbers. So that's group 1, 2, 3, 4, 5, 6, 7, and group 8, which is also known as group 0. The periodic table is divided into groups and periods. We've just numbered the groups. Now let us look at numbering the periods. So the groups are numbered 1 to 7 and then 0, or it's called 1 to 8. And the period number, as you would guess, just goes from numerically 1, 2, 3, 4, 5, 6, 7. Let us continue our notes by talking about the arrangement of the elements in the periodic table. So to begin with, we say that elements in the periodic table are arranged in order of increasing atomic number. That is, we read the periodic table from left to right. So hydrogen, helium, lithium, beryllium, boron, etc. The elements in the periodic table are also arranged into groups and periods. So for example, if I ask you for the period number and the group number of, let's say, potassium, you're going to look for potassium. Potassium would be in period number 4, group number 1. What about chlorine? Chlorine would be in period number 3, group number 7. You should, for the first 20 elements, if given a periodic table just showing the first 20 elements, be able to assign the group number and the period number and hence work out period number and group number for an element. On page 48 in the textbook, let us look at some of the names of the groups in particular, as opposed to the periods, which are just referred to as period 1, 2, 3, 4, etc. The groups, some of the groups have particular names. For example, group 1 here is referred to as the alkali metals. Group 2 is also referred to as the alkaline earth metals. Group 7, which is here, which includes fluorine, chlorine, bromine, iodine, that is referred to as the halogens. And group 8 or group 0 is referred to as the noble gases. You should also know that the group of elements between group 2 and group 3 are referred to as the transition elements.